Hello everyone. Thank you so much once again for joining us. So in today's session, we'll be learning about Kubernetes. So as you can see here title, it is mentioned as Azure AKS Kubernetes. But before that, we will try to understand what is Kubernetes first, right? So I will just take you give you some notes. Basically, there is official documents where you can also refer it. This is the official website where you can also visit here and learn more about the definition for each service, right? So example, as I mentioned, first we'll try to understand what is Kubernetes, and then later we'll try to understand the architecture of each component. Okay. Now, when I say Kubernetes, before that, we need to understand the Dockers. So in our till our last session, right, we have learned Docker's basic activities like networking, volumes, Docker image, Docker file, containers, what is orchestration, everything. We understood the concepts, right? Mean containerization concept. But today we are trying to learn about Kubernetes. So as you can see the definition, Kubernetes also known as K8s. We can know as a K8s is an open source system for automating deployment, scaling, and management of containerized applications. Now, before that, as I told you, if I refer to documents for the last class, that is docs. So I'm just giving an idea so that you get some idea this thing, right? Maybe I think I have it docker for this one. So as I told you, these are things we have covered till our last session, right? So you can see here getting started with Docker, then image creation and management, everything. So including the volumes also. So what basically we are doing Docker part? Docker part basically, let's say you have an application. It could be any application. Take an example of you have a .NET based application. This .NET based, what we did, we want to build as a containerized. So what we did for that, we have written the in our case, it could be a simple, but just giving the idea, right? So let's say what we are need to first create Docker file according to applications requirement, right? Or maybe projects requirement. So based on the applications, let's say, as I mentioned, we are going with the .NET based application. So specific for the .NET application to run, you need to have certain dependencies file to right. In order to create all these, we can do in fact manually. Let's say we can install all the application components or maybe dependencies manually as well, right? One by one using commands. But here the problem is this is all manual process. This is the reason why we have automated that process with the help of called Docker file. Because in a Docker file, we have defined all the instructions to build the application for particular that is a .NET, right? So now the application has been basically containerized with the help of container. We call as a container, right? We have containerized that application. Now question is, where are we going to deploy the application now? We need to deploy some environment, right? So where are we going to deploy that one? This is the reason why now we need to understand this concept that is a Kubernetes now. So if you see as the name this thing, right? It is an open source system for automating deployment, scaling, and management of containerized applications. Containerized means, as I mentioned, the image or the application which you already build it with the help of containerized image, or you can call as a Docker image. Where are you going to deploy that one? You cannot technically say as a Docker image, or in this case, technically you can call as a containerized image once it is built it as a application. Like that means once you containerize that one, it will be known as a containerized, okay, image. Now this one, in this case, as I told you, where are you going to deploy the containerized applications? It could be any application, say for example .NET, right? So this is the reason why this Kubernetes can help us deploy, right? That can automate deployment, scaling. They can scale the applications, then also manage everything in one place. This is the reason why we need to understand this concept. Now, if you can take a look little down, there is also given some notes. This is as an official documents. You can also refer these documents if you at all need. It is given somewhere. I'm just trying to find it. As you can see, this is some of the features you can see, right? So automated like Kubernetes, say for example, automated rollouts and rollback. If there is any issue in the applications, also that can be, you can roll outs or and rollbacks, depends on the issue or maybe situations. You can go through the its definitions, and also service discovery and load balancing. That means as you can see, right? So no need to modify your application to use unfamiliar service discovery mechanism. Kubernetes gives pods their own IP address and single DNS name for a set of pods and can load balance across them. So we will discuss that later anyway. And then we have a storage orchestrations, then secret and configuration management. So all these are possible. This is all part of your Kubernetes features. So now I hope by now you have got some idea, right? What is Kubernetes means? Kubernetes basically nothing but once you containerize the applications, this is the platform basically as an open source where you can automate the deployment and scale that and manage the containerized application in one place. Okay. So now let's understand the Kubernetes part in our, what do you call Azure Kubernetes. As I mentioned, these are the components where basically service we are going to be covered. So, but as I mentioned, we are not going to cover everything here, but we'll try to cover almost everything. We'll try to understand first what is, we'll try to understand the architecture of the Kubernetes, then what is pod, replica set, deployment, rollbacks, and so on. As you can see that these many things we'll try to understand one by one. All right. Now, so as I told you, first we'll try to understand the introduction to the AKS. Now, AKS also known as your Kubernetes service. Now, AKS is highly available, secure, and fully managed Kubernetes service. So we have two type of Kubernetes. One is a managed and this thing, right? This one is a managed service. Managed service in the sense every single component which is provided as a service by Azure, it will be managed by Azure itself. Means you are going to use as a service this one. Okay. So as of now, it is available in, especially I'm talking about Azure case, it is 36, but right now it will be more than that, right? That many region right now it is available. And then when compared to other cloud providers, AKS is the one which is available in highest number of region. So let's say talk about the AWS or maybe any other GCP and all, they'll having maybe 20 region something. But when it comes to the AWS Azure, we'll have more than I think now to more than 40 plus region we'll have. Okay. But here as you can see 36 till then, but now it will be more. If you can, maybe we need to read the documents, then you'll understand. Okay. Then you will be able to run any type of workload. So as I mentioned, once we containerize the application, it could be .NET, Java, Python, or maybe IoT, any kind of workloads can be deployed or managed. Now, like example, you have a Windows-based application like a .NET, then Windows-based application, say for example, Java we have, and IoT device deployment and management on demand depends on this thing. And machine learning is something that is this thing, right? This also we can distinct. Now, let us understand the architecture. First thing, what we need to understand here is the architecture of the Kubernetes. There are two things we need to understand. First, as you can see on your right side, sorry, left side, this is called as a control plane. On the another side, you can see as a node, basic node poles. What is control plane and a node poles? We will try to understand. So master we all know, right? Master we call as a master nodes and a worker nodes we call. Normal in the normal way we call as a master node means that is a control plane. And another way, worker nodes is nothing but your node pools. So in the master node, what all components we can expect? We have something called as a container runtime. What is container runtime now again? Container runtime is nothing but the application to run for this thing. You need to basically containerize the images, right? So in order to do that, So we need to install a Docker, or I can call as a we install Docker engine. We might have already learned in our Docker session, right? Docker engine. So Docker engine, similar way, whenever I want to run any application as a containerized application, I need to install Docker. And there is another container runtime. This is not the only the reason why Docker is used here. There can be any other, let's say, runtime. Container runtime can be Docker D as well. Okay, but as we are familiar with the Docker, let's talk about a Docker as a runtime. Sorry. Then next we have a XCD. This is also part of your master basically component nodes. And then we have a kube scheduler. Then we have a kube API server and AKS control. Sorry, kube controller manager. Again, you can call as control manager. Controller manager. Same way, when it comes to the node poles, they have a multiple worker nodes. As you can see here, worker node 1, worker node 2. So within the each worker node, for each worker node, we'll have a container runtime again. This is again container D or Docker. In our case, it is a Docker. Then also we have a kubelet. Then the kubelet communicates to the basically the kube scheduler with the as you can see, right, they have to talk each other. We'll understand the components definition first, and then I will explain the architecture once you're good with the what components we have with both master and the worker nodes, or I can call as a control plane and the node poles, right? Right. Then we have in the worker nodes, we have a kube proxy. Now, as I told you, now these many things we have understood the components we have. Now, if you go for master node, within the master node, as I mentioned, we have a kube. First one is a kube API server. What is API server? Kube API server. It acts as front end for the Kubernetes control plane. Control plane means this is basically a master, right, master node. So this will be act as a front end for the Kubernetes control plane. It exposes the Kubernetes API. Command line tools like kubectl, users, and even master components like scheduler, controller manager, XCD, or worker nodes, that is components such as kubelet, everything talk with the API. So it says that, so that is very major. This is a major components in your master node. That is your kube API server. This will act as a front end for the application. I mean Kubernetes for your for your master node basically. Why they will act as a front end? Because they are going to expose the API server. API server means because Kubernetes talks to the API, right? Once they expose the API server, let's say I want to talk to some other components, right? Let's say I have so many components, right? This is all part of your master node. Now, let's say this kube, what we call kube API needs to talk to the other this thing components, or maybe XCD, or maybe kube scheduler. As I mentioned, all components they have to talk to the kube API server. Okay, why they have to talk? Then we will understand that later. Okay, so this is how it is. And then next we have a XCD. XCD is nothing but consistent and highly available key value store used as Kubernetes backing store for all cluster data. It stores all the master and the worker node information. That means there is something called as XCD. XCD is basically consistent and highly available key value store. Key value store like such as you would have details or the let's information about the master nodes as well as the worker nodes. Okay. Then we have a kube scheduler. Here, as you can see, right, kube scheduler is responsible for distributing container across multiple nodes. That means scheduler, or we can call as a kube scheduler, right, is responsible for distributing container across multiple nodes. Say, for example, you have a .NET application now. You trying to deploy into the Kubernetes now. Now we have something called as a, we will come to later, something called as a pod, right? We will understand that also. Pod is the smaller unit in your Kubernetes. That means a deployable unit, right, in your Kubernetes. So that means whenever I want to run my application, that is my .NET based application or maybe Java, right? So where are we going to deploy them? we have to deploy in our cluster, that is in the cluster, right? Kubernetes cluster. But exactly where in Kubernetes cluster it is going to be deployed. So we have something called as a worker nodes. So under worker nodes, within the worker nodes, we have something called as a what I call containers. Under containers, we can have a multiple pods. Within the pod itself, you are actually going to deploy your applications. So for each pod contains one application. That means if you have a .NET based application, so within the node itself, we have something called container. Within that only will have your application running. That is your inside your pod basically. Okay. So pod is nothing but it is a one-to-one relationship. That means only one application in one particular pod can be deployed. That is the smallest you can sell or smallest deployable uh, application in your cluster. We will talk that later, but for now understand. So let's say I want to deploy that application now. Now how the Kubernetes will understand where the application need to be deployed, right? This is the reason why this particular kubescaler is responsible enough for distributing where to deploy that particular application. So they will take, let's say, if there is any application which you deployed with the help of Docker image or sorry, I mean, once you deploy that one, they will decide where your applications must be running or deployed. Okay. Example, as you can see here, it was just for the newly created pods with no assigned nodes. So as I told you, the pods is running inside a node, right? So and selects the node for them to run. So they will select particular node because node is just nothing but we will come to the point again. Node for now, just understand it is just a normal virtual machines set of virtual, just a normal virtual machines, right? Where it has a certain memory, RAM, all the configurations for your application to run. And within the VM, let's see in our case, let's talk just a simple case, virtual machines. We are going to deploy multiple application with the help of what containerization concept. So this is why the Kubernetes can help you us here. Okay. Now we have kube controller manager. Controller managers are responsible for noticing and responding when nodes, containers, or endpoints go down. They make decision to bring up new containers in such cases, right? So there are many different types of controller managers are available. Example, you can see this is a node controller. As you can see definition, responsible for noticing and responding when node goes down. This will be only focused on the node level. If any node is down, node means as I mentioned, just think of a normal virtual machines for now. Okay. So if any reason that it goes down because all your application is actually running within that virtual machine itself. Now let's say your virtual machine itself down mean definitely your application is going to be down, right? This is the reason why this node controller can help us by noticing and responding whenever node goes down. Similar way, we have another one. This is a replication controller responsible for maintaining the correct number of ports for every replication controller object in the system. So this is another type of controller. This will be more in details. You cannot, I mean, for now, you don't need to understand that in details, but then you can understand in the high level, right? So replicas is nothing but whenever I want to deploy any application, I would say how many replicas I want in the sense how many number of same application I want to run, basically number of pod. Pod, as I mentioned, it is nothing but it is a smallest object where deployable unit where you can deploy your applications, right? So that means now let's say I have a Java based applications that I want to have a setup two. That means two same application will be running in two different pod. That means I will mention replicas is equal to 2. That means the same number of application, that is a Java application, will be deploying two set of applications. That will be same identical. The reason is why are we doing that? because if one pod goes down, still the same application will be running into another pod. This is the reason. Then we have an endpoint controller, popular for endpoint object that is joint service and pods. So as I mentioned, we don't have to go that in details for now. Just understand this level for now. Con- Controller, okay, that is a controller manager. Cube controller manager, that is a high level. So what it is going to do? Controllers are responsible for noticing and responding when nodes, container, and endpoint goes down. For now, just understand this one. Okay, they make decision to bring up new containers in such cases. So if there is any issue with your node or maybe endpoint, maybe containers or anything, maybe endpoint goes down for any reason, then this controller manager is responsible for them to bring it up. Okay. Now let's go to the next. As I mentioned, there's something called as also another. This is focused on the cloud controller manager. This is focused on the only cloud services. Now, a Kubernetes control plane, that is a master node, right? Component that embedded cloud specific control logic. It only runs controller that are specific to your cloud providers. On-premises Kubernetes cluster will not have these components. As I told you, this only focus on the cloud. All right, this, as I mentioned, we don't have to think much about these components within the controller manager. Let's not discuss this one in details. We will come back later when required. Okay. Now we have understood the overall understanding about the master node. Now let's understand worker nodes, or we can call as a control plane, right? Sorry, not control plane, node pool. Now, as you can see here, under worker nodes, we have a kubelet and proxy, and we have a runtime, that is your Docker. Here, first let us understand what is kubelet. Kubelet is the, if you just here, kubelet is the agent that runs on every node in the cluster. That means kubelet basically is nothing but it is an agent that is running in every single node in your cluster. Node mean in your virtual machine. You just think for now in your individual cluster. Node basically it is going to be running agent. This agent is responsible. What is agent going to help us, or what is the responsibility for this agent, right? So this agent is responsible for making sure that containers are running in a pod on a node. As I told you clearly, right? The containers basically nothing but the application which you have already containerized, that will be running in a container. So containers will be running where in your pod, where exactly in your particular node, right? This is why I was saying it. So the agent is nothing but they are responsible for your containers are running in a pod on your node. Now next we have a kube proxy. What is kube proxy? It is a network proxy that runs on each node in your cluster. That means before having a kube proxy, you cannot do something, right? So you need to have the kube proxy so that they can run in each node in your cluster. Let us see why it is useful. It maintains network roles on the nodes. In short, these network roles allow network communication to your pods from network sessions inside or outside of your cluster. So as you can understand, right, this network allows network communication to your pod. So basically, this is basically for communication purpose between your pod from your network as well as outside and inside, okay, of your cluster. So now we understood the high level what it does, right? So similar way, when I say the container runtime is the underlying software where we all, sorry, we run all these Kubernetes components. We are using Docker, but we have other runtime options like Rocket, Container D, etc. As I mentioned, there are others as well where we can use it. So I hope by now you have some understanding. Now let's understand once again. Coming back to this point now. Okay. Now coming back again to the previous architecture. So as I mentioned, the definition was somewhere you got some idea. I'll give a high level of in the simplest way now. So when comes to the Kubernetes architecture, we have a two part. One is your master, or we can also call as a control plane. But technically, we should not use a master this thing. We can call as a control plane. Okay, similar way for the worker node, we can also call as a worker node, but still technically maybe when it comes to the Azure, we can call as a node pools. Okay, that means we have two in the high level we have two things. One is a master and the second is a worker nodes, or you can call as control plane and a node pools. Now let's understand each component. As I mentioned, the first one, it is your Kube API server. Now Kube API server is nothing but it act as a front end, right? It act as a front end for your cluster that expose the APIs that is going to this particular API server. They are going to expose the API. Why are they going to expose the APIs? Because they have to talk to each component. That means this particular API server, they are going to talk to XCD. They are going to talk to what you call scheduler. They are going to talk to controller manager. They are going to talk to what do you call this one, kubelet, and all other components. Whether it is for the master components or the worker components, but all these services are going to talk to the API server. Okay, that is the first thing. Then second thing is we'll try to understand that is your kube. You can call as a kube controller manager or controller manager. You can call both are same fine. This work is whenever any components down. Let's say you have some components down. Let's say within this one we have a control manager. Right, we have this is called a controller manager, right? So let's say your endpoint goes down, or let's say your particular service down, particular something's not working, right? Fine. Then how are you going to basically identify which is down when, right? So this will be taken care. So as I mentioned, within this controller manager, we have a multiple components such as controller call replication controllers, we have endpoint controllers, right? We have many others, right? So this is a in details, but on the high level, the controller manager is basically they are trying to understand whenever if the particular is not working or as expected, they're trying to figure out and make it redundant. Okay. Second thing is XCD. XCD is nothing but a key value. As I mentioned, it basically stores your informations of your worker nodes as well as your master node, whatever components we have, right? So all the information will be stored in your XCD. Then we have a kube scheduler. Kube scheduler is nothing but whenever your application you deploy into the you application, let's say you deploy the application, it is going to be running in a pod, right? So whenever new pod is getting created, so the pod need to be running in certain what do you call node, right? So but then how the Kubernetes will decide which node, because I'll be having multiple nodes. As I mentioned, node is nothing but for now just think of a virtual machines. How the Kubernetes would understand where my application, that is your pod or containerized application, need to be deployed, right? The pod need to be deployed in certain node, right? Then only they can run the application. So who will take the decision? That one. So this will be taken by decision with the help of Kube scheduler. They will take a decision where to deploy which particular node your application can be deployed. Okay. Next is your runtime. As I mentioned, runtime is must something because this is all the underlying things where your application can run, right? So because without having the runtime, you cannot, that is your Docker, maybe any other this thing, you cannot run your this thing application. Now coming to the worker nodes or call as a node pods, same as just like here, we have also container runtime, that is your Docker. We have kubelet. As I mentioned, kubelet is nothing but it act as a agent. So agent work, what is responsibility here is basically if they will try to see if they're able to communicate each other, right? For each components we have. So that is the thing. And then we have also kube proxy. It is a network basically proxy we can call. how the network can be communicated. Sorry, your application can be communicated. Whether you want them to block or you want them to allow or you want within the port to port, you want them to talk to each other or how you want them to manage, right? This all will be done with the help of Kubernetes, sorry, kubeproxy. Okay, all right. Now let's understand the so this is some of the fundamental components we have. That is a pod, replica set, deployment, and service. So we'll try to understand each one. As I told you, understand if you're when comes to the architecture level, you will have some idea. Now let's understand the components. Now these are the some of the key components we have: pod, replica set, deployment, and service. Now when coming to the pod, what is pod? Pod is a single instance of an application. Now it is very clear. As I told you, pod is a single instance of an application. That means in one particular pod, you can only have one application running. Okay, pod is the smallest object that you can create in Kubernetes. This will be the smallest object in your Kubernetes that you can create, right? So similar way, when comes to the replica set will maintain a stable set of replica pods running at any given time. In short, it is often used to guarantee the availability of a specified number of identical pods. So replicas is think of a number of pods. Let's say I want to run 10 number of pod at any given time. Let's say that means 10 same application will be running in 10 different pod, right? Now let's say if one of the application goes down, that means one of the pod goes down for any reason, then how many you will have? You will have a 9. But if you do not have the concept called as a replica set, what is going to happen now? Your application will be running fine, but then it out of 10, as I mentioned, 9 is going to be run, not 10, because one is down for some reason. Now, in order to maintain replicas or pod is equal to 10, that means 10 replicas if you want to manage any given time, whether it is for any reason, whether you want to maybe it is got crash or maybe the report got down or crash, something happened also, but still I want pod 10 is pod, that means 10 application in the same pod need to be running. In this case, what I can do, I can just simply mention replica sets as 10. This is why it says the definition will maintain the stable set of replica pod. That means that many replica set they will maintain at any given time. Whether for any issue also they will try to maintain this many number. Okay. All right. Now deployment. Deployment runs multiple replicas of your applications. So deployment runs multiple replicas of your application and automatically replace any instance that fail or become responsive roll out rollback changes to application. Deployments are well suited for stateless applications. So mostly we will be working with the deployment level, but then if you still work on deployment, you still need to know pod also, because within the pod itself your application will be running, as I told you. So let's say if your application is not working, you need to troubleshoot, right? How are you going to troubleshoot? You have to check the deployment configuration. You need to check the port logs. You need to check the status of the pod, whether it is pending or having any issue, right? So as I mentioned, pod is this basically smallest unit where particular application runs there. This single instance. So this is what it is. So because when comes to the deployment, it has the advantage of automatically replace any instance that fails or become unresponsive, roll out, roll back changes to applications. These all features are available in your deployment. Then we have a service. Service is a abstraction for pods providing stable so-called virtual IP address. In simple terms, service sheets in front of pod act as a load balancer. So we all know whenever application wants to talk to somebody or outside of your wall, right? Somewhere you have a service to be exposed, right? Otherwise, you cannot talk outside of your wall. I mean, network or maybe company. So similar way, even in your Kubernetes case also, we have something called as a service, right? So this will be sheets in front of your pod, in front of your application basically, so that you can take a decision whether you want to talk to certain user or not. So we can define certain policies according to that also. Then we have, these are some of the things, components, as I told you. We will try to understand imperative and declarative, right? So imperative something, what is imperative and the declarative? Imperative is something what you can give a commands using like CLI, you typing some commands, right? And second one is declarative using YAML. That means YAML, YAML and kubectl we can use. So if you can see this, it supports in the imperative, we supports the kubectl, like just like running the commands, right? Similar way, in declarative we have a YAML as your kubectl. So what is YAML also we have already covered last time, but we will see here also how we can create the resources with the help of YAML. Okay, these many things are supported in when it comes to the imperative, and when it comes to the declarative, these many services are supported. Now, let's understand one in the simple scenario. Like we'll talk about the pod. With Kubernetes, our uh, code goal will be deploy our application in the form of container on Worker nodes in your AKS cluster, or you can call as a K8s, right? K8s cluster. Now, Kubernetes does not deploy container directly on the Worker nodes. As I have already mentioned, your Kubernetes does not deploy your containers directly on the Worker nodes. Let's say you have a image call. We have already learned last session, right? Docker image, how to build it with the help of Docker file. So we have built a Docker image. Similar way, we have a Nginx container image we have now. Okay. Now, container is encapsulated into a Kubernetes object name, that is your pod. Now, say for example, we have a cluster. Under cluster, what we have a Worker nodes, right? Under Worker nodes, we have containers. Container, what is a container actually? Container is nothing but it is an isolated environment, lightweight and isolated environment that has all your application components, such as your application configuration, system libraries, or maybe any binaries or anything that requires for your application to run, right? So these all components are there where into your container. So that means they have containerized that one as a containerized image. The containerized image where it is going to be running, this will be running in your cluster under Worker nodes. There is something called a pod, right? So with basically the containers we'll be using inside basically in the pod itself. Okay. Now, as you can see here, a pod is a single instance of an application that we already discussed. So pod is nothing but it is a single instance of your applications. Now, a pod is the smallest object that we can create in Kubernetes. Now, pods generally have one-to-one relationship with containers. So as I mentioned, pod basically works as an individual application, right? So similar way, as you can see here also, pod generally have one-to-one relationship with containers. To scale up, we create new pod, and to scale down, we delete the pod because it is one-to-one. So wherever there is a more traffic, definitely you need to create a, or depends on this thing, you need to create more new pod. If less traffic, maybe you have to reduce the number of pod, because as I told you, pod is basically it's a individual or basically a single application running into your particular pod. Now let's say we have a AKS cluster, or sorry, we have a Kubernetes cluster now. We have worker nodes 1, worker node 2. In the worker 1, we have something called as basically container, that containers image basically containers. Then we have a pod, right? On the pod we have a container. Then we now let's say, let me just see. Sorry. Now, if you can notice here diagram, we have a under worker nodes 1, worker nodes 2, we have multiple Docker images running here. So each node can have a multiple pod running in a container basically. Okay. Now we cannot have multiple containers of same kind in a single pod. I have told clearly that in one particular pod only one application can run, right? But carefully understand here, we cannot have multiple containers of same kind in a single pod. That means in single pod should be only running one application, same kind. But there can be a situation where in the same pod also we can also have two different purpose. We can have example, two Nginx containers in a single pod serving same purpose is not recommended. That means we have a two like containers, that is your Nginx, right? With the same purpose, you cannot use this what they call in one pod. So yeah, so as I mentioned, now you can see here, now this is a pod, right? So yeah, so it cannot be supported because if you see here, this is a worker node 1, here we have Nginx, here Nginx, right? Here Nginx, this is one separately. Here if you see here, this is Nginx, this is Nginx, just in the same pod, they should not be used same containers in the pod because they are same image, right? Same purpose. So it has to be run only one. Same way, if you have the pod, as they are different, same worker nodes, but if you see they are isolated containers, right? They are isolated. So this is different pod, this is different pod, right? They are not together. If you see this is together, they are different. So this can be run in the same node. Okay. Now Kubernetes multiple containers pod. Now we can have multiple containers in a single pod, provided they are not of same kind. So it says that even if we want, we can have us in a single pod, we can have multiple containers running, but then it should not be the same purpose. It can, if this is there are two different scenarios. Yes, you can use multiple containers in single pod as well. Let's see what it is. Now, say for example, if you can take a look closely, in under cluster we have a worker nodes. Under worker nodes we have a nodes. There we have a multiple containers. Container 1, that is your Nginx. So another content within this is within a pod, right? Within a pod we have a Nginx running. Another in the same pod itself we have another H. That means this is a helper container. That means one is for Nginx, second is for the what you call helper container. So in this scenario, if you want to have two different containers running in the particular pod, yes, it is possible, but it can be, it should not be the same purpose. It can have a different purpose. One is the Nginx example, second is a helper container. So to do some this thing, like helper related things in your container. So in this case, yes, you can use two different containers within your pod itself. Okay. Helper containers, like a say example, we have a sidecar data pullers. Pull data requires by main controller, data pushers, let's say push data by collecting from main container. So this kind of something you want to do it, right? Some activity for this. In this case, because they are serving two different purpose, of course, yes, you can go ahead and use this multi containers within the pod also. Now communication. The two containers can easily communicate with each other easily as they share the same network space. So of course, when coming to the network perspective, because they are serving same this thing the port, right? They are using the same port, that means same network. So of course they will be able to communicate each other. They can also easily share same storage space. So that will be common. Yeah. So multi-container pod is rare use case and we will try to focus on more core fundamentals. So we'll see more into this service. Now, then we will understand the service that is a load balancer. Now, what is load balancer? Uh, in example, whenever we create any Kubernetes service, right, I will show you that as well. So by default, there is a load balancer. We all know we have in Azure load balancer service, right? So what are the load balancer? It is basically to distribute the traffic among the backends, right? If you have a two different backends, let's say same traffic comes into your applications, they can route the traffic to certain backends. So basically to distribute traffic here, they work as a layer 4, basically, right? So we can expose an application running on a set of pods using different type of service available in Kubernetes service. Okay, cluster IP, as I mentioned, when I say the service, that is a load balancer, this thing. Now we have a, as you can see here, cluster IP service. This is a type of service in Kubernetes. That is, this will be used only for the internal to a KTS cluster. That means when I say cluster IP means this only mean for the internal to cluster, Kubernetes cluster. That means if you want to have communication only within the internal as well as the this thing within the network to the cluster, that means within your this thing, right, applications, then you can maybe use this type of service, that is a cluster IP service. Maybe if you want to expose, let's say you want to access to the network, then maybe you have to choose antenna. If you want to access to the net outside of your wall, maybe we can choose NodePort service, and we also have to antenna one more is a load balancer service, and one more we have to antenna one is a ingress service. What is all this we will understand as we learn, right? So if you can see these three almost same, one is your NodePort, second is load balancer, then what is ingress, we will understand slowly that. But for now, just understand that's one. This is for internal, rest all are external. Now, load balancer service to access our application outside of Azure Kubernetes service cluster. We can use Kubernetes load balancer service, which will be eventually mapped to Azure load balancer, Azure standard load balancer. So that means whenever you basically try to create any new cluster in your Azure service or Azure Kubernetes, basically there, um, you are going to create by default whenever you create the cluster itself, this Azure load balancer is going to be created for you and mapped it. Okay, this will be mapped automatically. So we will see this also later anyway. Now, as I mentioned, we have a cloud service, then we have a cluster. Under cluster, we have this is basically load balancer will be created. And here we'll have a Azure cloud service. There we'll have a load balancer is going to be created as part of your cluster. And we have a node worker nodes. And the worker nodes we have a pod. Inside pod we have a multiple containers running. So example, this is the Nginx application. This thing. Now we have a service because now this application will be basically running, right? Now I need to access it or maybe do something, right? There is something called a service, right? Sorry. Yeah, service. Now if you want to communicate cluster IP service, right? Cluster IP service, as I mentioned, if you want to talk within the network, right? Is within the basically what I call service, not outside, then you have to basically use this one cluster IP service port. Also, we need to define when we expose the IP service, you need to define the port also, that is port 80. Okay, then target port. Target port means basically this is a you will have a two port. One is a cluster, second is your container port. Container port where your application running. So that will be port 80 because engineers, we know, right, this application whenever I want to run engineers, as I mentioned, it will be run on the port 80. So yeah, now we have the this all we have also, right? Now updated standard load balancer with front-end IP and Ruby here. So whenever you create a Kubernetes cluster, by default the standard load balancer will be created. Along with that, there is something called front-end IP and the load balancer will be created. Front-end IP means why front-end IP is required, because as we all know, load balancer is used for to distribute the traffic. I mean for to distribute the traffic among the backends based in the load. Request, right? Let's say if one particular backend is having a lot of traffic, huge traffic, maybe another backend has a less traffic, then they have to understand based on the rules, right? Based on your load balancer rule, they will route the traffic accordingly. So this is the reason why this Azure standard load balancer can help us here. By default, they are designed by default. But for your reference, for your information, even if you do not want to use this one, by default it is going to be created. But if at all not required in the future, maybe I want to go instead of the load balancer, can I use some other load balancer? The answer is yes, you can. Okay, then what would be other service name then? Which one should I be using then? Apart from the standard load balancer, what other service can I use, right? You might be hearing there is something called as a Azure Application Gateway, right? Azure Application Gateway also works on layer 7. It has a much more features when it comes to the load balancer. That is your layer 4. And the Application Gateway works on layer 7. Okay, so we can use that one. Otherwise, we have a ingress controller, which I mentioned. No? We have another concept, basically, this is something called as the Nginx. Okay, in Nginx ingress controller, we can use that also. So we will think that we will talk that also later, but for now, understand load balancer, we are going to use it. Now, when we deploy a Kubernetes load balancer or Kubernetes load balancer service, the following will happen in Azure load balancer. As I mentioned, a new public IP gets created and associated to the front-end IP. So by default, public IP will be created and it is going to be associated to your front-end IP. Why front-end IP is used? Because front-end IP is nothing but all the communication, it is going to happen through the front-end IP. Front-end IP is just like your key. Without having the key, you cannot access inside your cluster. Same way, or think like a security. In the main gate, there will be security, right? So without having the permissions to the this thing, security will not allow you to come inside, right? Come in, right? So same way, think of this is also. So whatever traffic comes, whether it is in and out, whatever it is, so everything has to come through the front end IP itself. Because let's say if I have application called as a facebook.com. Now facebook.com, it not mean that only one server will be running. There will be hundreds of basically same set of application will be running, right? But then for this application will be running in different region, different server, right? Now question is, let's say same application, same domain name, that is your facebook.com, but I have deployed same application into multiple server. Now whenever I request, let's say I want to log into the Facebook, how I'm going to basically reach to the facebook.com, because there will be multiple server. This is the reason why we need to use a front-end IP, because front-end IP with facebook.com, whatever your domain DNS name is there, the front-end IP will be only one. But inside that, backend will be multiple. Backend in the sense multiple server. That means to run your Facebook application, you can have a 10 or 20 or 100 of configure same virtual machines or the server. But then while mapping, how it is going to have map them, they will be mapped with a front-end IP. Front-end IP in the sense only one. That means any traffic, whenever they want to reach out to the facebook.com, they have to come to this IP. That is your, they'll be having one default IP with some IP range, okay? IP for front-end. And in the backends, the front-end with your DNS name, maybe that would be, let's say in our case, let's say facebook.com we have it. They have to map them. Once they map them, based on the traffic, in the backend, they'll be having, as I told you, multiple backend pool they'll be having. So they can route them based on the traffic. And also depends on the technique they use. They could be having some mechanism to route the traffic. Maybe based on the user experience or user based on the region. There could be many different type of load balancer of, the mechanism they can use. Okay. Same way here also we can think of that. Okay. Then a new load balancer role will be created with associates front-end IP and a backend pool. As I told you, they will associate, they will take care of everything backend. This all you do not have to do anything manually. This all will be done backends by Azure itself. This is why it is so much easy now to use Kubernetes service. Okay. Okay. Next. Now example, as I mentioned, now we have a user here. User want to access something dot something IP they have. They want to access. The traffic need to go to the firewall first. Sorry, firewall in the sense you load balancer. Now load balancer, as I told you, will have a front-end IP, right? Now the front-end IP with your this thing, whatever Nginx you are running here. In Nginx we have application running that they have to map them, right? So whatever role you're doing, if you can see backends, we have a backends, whatever is that, they will map them together, right? Where you want to route the traffic. So this all defines by Azure itself. So they will directly hit to your load balancer IP address, and based on the backends, the role you define here, then they will take a decision where to route the traffic. And also while defining the role, where is that role name? Sorry, I think yeah, LB name, right? Role balancer role name. This thing. That time you need to define what is a port you're going to listen, what is a application type, what is a protocols, and everything. It is going to be defined in your load balancer role. Okay. Now, as I told you, whenever this person hits there, it will go to the load balancer. Now, load balancer based on the this whatever port you expose it, whether it is able to access or not, they will see this one. As I mentioned, they are going to expose port 80 this as a service and container port as a port 80. Now they can access your applications. That is your Nginx, because Nginx, as I told you, that is a target that listens on port 80. So which service, as I mentioned, the IP also, whether you want them to access from the outside or not, this is your decision. Whether this is why the service type, what we mentioned here, can be changed according to here. As I mentioned, this is for the cluster IP, so it can be this thing. But if they are using any other service type, then in this case, it can be a different scenarios. Okay. Okay. Now we have like Kubernetes pods, load balancers here. We will understand. Now we will understand replica set. Okay. Replica set, highly available or reliability, scaling and load balancing, they can have it. And also levels and the selectors. So we will come the points. What is level and selector? Why we need to use? Okay. Now, a replica set purpose is to maintain a stable set of replicas pod running at any given time. That, as we all know, that means if you want to find a 10 set of pods running at any given time, then you can mention replicas is equal to 10 in your YAML definitions, or maybe deployment, whatever you define. Okay. If our application crash, example, any pod dies, replica set will recreate the pod immediately to ensure the configure number of pods running at any given time. That means, as I mentioned, if for any reason your application got crashed, that means your pod is got crashed or maybe died, something happened. That means this because they want to maintain 10 right instead of 9, so they will try to recreate with a new name, new port name. They will try to recreate. Okay, this is the beauty of uh, replica set. Example, we have a cluster. On the cluster we have, as I mentioned, on the cluster we have worker nodes. On the worker node we mentioned a replica set, right? Replica set, if you see here, there are right now they have given 2 replica set, 3 total, right? Out of 3. Now in 3, let's say if for this particular pod, this is, as you can see, they are all same application type, right? Within the replica set they given as a 3 replica set. In that they are running the same type of application, right? All are Nginx. Now let's say one of the pod is crash or happen something or down, right? So by default, the replica set, if you mention as a 3, then automatically they are going to create new replicas with a new name, new port name basically. Okay, this is why this we can call as a reliability and a highability. Okay, then next, load balancing to avoid overload of traffic to single port, we can use load balancing. That's as I told you, because we need to see how the traffic is coming from, where it is coming, right? So we need to balance the traffic also between the pod also. This is why we have to use the load balancer so that we can balance the traffic based on the rule that you define in your rule, what is it, in your load balancer rule. Kubernetes provides pod load balancing out of the box using service for the pods which are part of the replica set. So whenever you define the replica set also, so as I mentioned, replica set mean basically the pod, number of pods. So for each pod would be using a one particular application, right? So that time we need to access the application, right? For each application I want to access it. So if you want to access to particular application, so we need to use the service here. That means we need to expose the service in order to use it. Maybe again depends on the scenario whether you want to have internal access or maybe external access. That is depends on your choice on the company standard. Okay, so labels and selector are the key items which ties all three together: pod, replicas, and the service. We will know in details when we are working. Whenever we are working with the YAML, then we'll, as I mentioned, we will understand that later. But for now, just understand this many, we have this thing. Now, as I mentioned, now we have a replica set here. If you see here, there are four. Here we have two, right? Here worker node. This is a worker node. Replica set mentioned. Here two, we have here two. I mean, total four we have. Now, this all service, if you want to access it, so what they can do, we need to expose the basically the service also for particular applications. Now scaling is something, okay, let's not go to this thing. Now, if you see the service wise, right, who is that? Yeah, yeah. Scaling, we, as I mentioned, when load becomes too much for the number of existing pods, Kubernetes enables us to easily scale up our application, adding additional pod as needed. This is going to be seamless and super quick. So whenever application, let's say having too much of traffic or maybe load, in this case, that means you need to basically increase the what is shared, basically your application, this thing, right? So how are we going to do it? In this case, we have to increase the number of pod. Instead of two, I have to make it three. That means by defining the replica set, this can help us. Okay. Demo, as I mentioned, we will cover later. So same way, we have the deployment concept also. As you can see under here, carefully listen here. This deployment, what we need to understand here is, first we have a cluster, right? Under cluster, we have a worker nodes. Think of this is a single virtual machines. This is also another single virtual machine, for example. Just think for now, this is a individual virtual machines within the cluster. Now, inside the cluster, now I have something called as a replica set, right? Inside replica set, let's say replica set I mentioned as a 4 for now. Now, and also we have a deployment. Deployment, why we use? Because within the deployment, we can define how many pod you want to run. So instead of creating one single pod, I do not want to create single pod. What I want is I want to create multiple pod so that many application can be run, right? So this is why this deployment comes into picture. So if you want to, let's say I want to manage all the pod, right? Let's say I want to manage all the pod and replicas and everything. How can manage? So with the help of deployment, we can manage. That means this has a must, what is it, feasible where you can manage a set of pod or replicas, everything with the help of this thing. Let's say one particular application goes down or maybe crash something. If you define within the deployment, if you define the replicas as 4, automatically another new pod is going to be created. But if you don't define the replicas, let's say 3, already you have a 3. I mean, if you don't define the replica set, then in this case, then whatever pod is going to create, it is going to create according to that. But then you cannot create, it is not going to create a new pod basically. So that is why whenever you use the deployment by default, you need to define the replicas also, replica set. Okay. Now, yeah. So in order to access all these one, So in the deployment, this thing we have to expose the service. So that's something we have understood. Now we will think about the deployment. Deployment basically create a deployment to roll our replicas, updating the deployment, rolling back and deployment. So these are all things we have this thing also. But as I told you, this is something I will cover maybe this thing. For now, just understand this thing. And the cluster level, service level, we have different kind of service. Uh, Cluster IP, NodePort, load balancer, ingress, and external name. These are all different services we have. Now, for each service, if you take a look, use for cluster IP, used for communication between application inside Kubernetes cluster. Example, front-end application accessing backend applications. So, same way for the NodePort, used for accessing application outside of Kubernetes cluster using Worker NodePort. Accessing front-end IP, you can see on. So, similar way with load balancer, primarily for cloud providers to integrate with their Azure load balancer service. Example, we have this thing, or we have Azure load balancer. And Ingress. Ingress is an advanced load balancer which provides context path based routing SSL and SSL direction, redirect, and many more. We have it, right? So as I mentioned, in our case, we can use SSL support and everything. No, we have the context path based routing. We have in Azure Application Gateway, so we can use it. But if you're going with AWS, we can use some other Azure, AWS, depends on that. You can use it. But yeah, then next we have external name to access external hosted application in clusters. Example, access AWS or RDS service. We can use this, but we are not going to use this one. Mostly in the real time, we are going to use cluster IP, load balancer, and ingress. These three mostly be used. I'll repeat again: cluster IP, load balancer, ingress. These three mostly you will get to see in your real project. Okay, because as you can see, definition it supports so many other things. Okay, anyway. Then now service. This is the last topic. Okay, so now as you can see service, now we have a deployment, that is a, let's say, app name is given as a backends, and deployment, then there is a replicas. You can see here they have a three different port running, that mean number. Now we have backends application, that is the backend, that application that will be used for a cluster IP. Deployment name is a front end. So in the front end IP, basically in the front end, they use this one 123 port, and name given, application name is a front end. Similar way for backends, they use as a app name as a backend, they use it. Now to access this one to the front end backend together within this thing, they can go with the what they call if you want to access the backend, we can use a cluster IP. So DB external service. Now this is for the backend side. They want to communicate to your outside of the somewhere they want to access. So we can go with the external name service as well. Now whenever user basically will be hitting directly to where the app, right? Front end app, and this is a front end, right? This is a front end app, the NodePort or load balancer or ingress. So we'll be using, so front end is something that is going to be exposed publicly, right? Because all, if you don't give permissions or expose the service, then definitely other outside of the network cannot communicate to your network, or especially in your cluster, right? So this is why we need to understand this thing here. Now, as I mentioned, load balancer or the ingress mostly we can use. Now let's see next. Now same thing. If you can take a look closely here, we have, as I mentioned, front end. We have a front end. We have a load balancer, and backends. This is a front end name given as a front end. Replicas as one. Similar way, backends we have a cluster IP, because backend they want to access particular this port. Okay. Now they'll be using as a backends. Now how the traffic coming also you can check here. They will hit. It will go to the front end applications. That is your load balancer service. From there, it is going to router. Now, from there, they'll expose the service to in order to access your backends application. Okay, I think that's okay. Yeah. So maybe that's it. Maybe what we can do is next week, right? So YAML, I think I can cover later. Yeah, not required now. So YAML part, what we can do, Steam. We will see how we can write YAML, why we had to use YAML, what is the advantage of using YAML, what is the different way of working with YAML, and how can we write different kind of scenarios in the YAML. So maybe if you remember in our last sessions, I'm not going to basically show you much, but then I'll just give you an idea. Try to explore if possible. Right. So last time I was showing you, right, there is an option where you need to install the extension. There is a button called extensions, I think somewhere. Yeah, right. You can type YAML. What you can do is, I would say, you can install the Kubernetes of this thing, because once you install Kubernetes, also YAML Kubernetes, type the Kubernetes or Azure Kubernetes, something like that. Now you can see, right? So why we need to use this one? You can see this is for the Visual Studio Code Kubernetes tools. So it can go through this many. There's so many features are available. So that means now, if you want to work with the Kubernetes related tasks, right? You cannot always remember that steps, or maybe sometimes you cannot remember the syntax also. So this extension can help you write better and faster. Okay. Then second is your YAML. YAML will give you understanding about how the syntax should be written, how it has to be organized, right? Syntax. This all, yeah, you can see, you can install this extension also. Okay, example, in my case, let's say I have already done, last time I was just showing you, let's say I want to type something, let's say I have created .yaml extensions. Now, let's say I want to create a pod, right? So as I mentioned, pod is the smallest object in your Kubernetes where you can basically deploy your application, that is right. So let's say I want to now create a pod instead of the replica share, or maybe service, or maybe deployment, right? If you want to create a pod, there is a different way of accessing Azure, but I'll just give some example how we can make use of documents as well. So maybe you can just go to Kubernetes documents, something like that. You can type. Maybe if you want to go through documents, you can. I'll just give you two scenarios, two example. I mean to say two example I'll give you. So one is using documents. So this is the documents that is officially available, where you can see what is Kubernetes, why to use, what are the components, everything we can understand. Let's take a look, small example. What we are going to do is that, let's say we are going to work with a pod. So let me see if I can find here. Yeah, if you type the pod here, by searching here also, pods, right? It is pods. If you type here, it will take you there. So that means under concepts, under here we can see here. So here now, let's say I want to create a pod. What is pod also? We want to understand definition wise. Pods are the smallest deployable unit of computing that you can create and manage in Kubernetes, right? Pod is a pod in a pod of wells, or pod is a group of one or more containers with tail storage and network resources. So you can take a look later, but we are not trying to understand for now, but you can see here. Now, example, using pods, the following is an example of pod which contains of a container running an image that is Nginx. That means I want to create the Nginx pod. Basically I want to containerize this, right? I want to create this thing. So how can I do that one? So this is the reason why I can make use of this one. That means first, as I mentioned earlier, whenever I write YAML, especially for the Kubernetes YAML file, we need to keep in mind four things. First thing is API version. The question is this API version. Second is a kind. Third is a metadata. Four is a specs or specification. You might have a question like, is it lag, or do I need to mention follow the same structure? Structure in the sense the organize, like first I need to define the API version and the kind. But answer is no. It is not strictly says anywhere that you have to follow exactly as it is. You can define first kind, then API version also, no problem. But then this metadata too can be always better to keep at last. But then these first two, you can interchange this one if you want. But then best practice to follow according to the documents. So what four things: first API version, then kind, then metadata. Now why are we require this one? Now now if you see here, this is just to create a simple pod. Now to create pod shown above for this, now I have created, this will be created if you see here under pod sample.pod.yaml. That means this will be in the YAML syntax, right? Now in order to write the syntax, there are two ways of writing. As I told you, one is referring the documents. That is one more thing. Second thing, if you don't see this useful, maybe if you want to explore more and learn more, but I would always suggest refer documents. This will help you a lot. Now in the syntax also you can see here. The question is how the syntax are coming like this, right? The first thing is that they are talking about what because as I mentioned for each API versions, if you remember in our class, I think some here I mentioned, right? Every single things are right. It is coming through the API server, right? API version. So somewhere you need to have this thing, right? That means your pod also application need to listen on certain things. So that is why you need to define the. That means for each components in your AKS service, they work on the API basically. So now, if you're talking about the Kubernetes pod, in this case, this is the version they are using it. Say for example, if you're using the replica set, maybe some other version they are going to use. I mean application, actually API version. So let's see how we can write. So this way, one way of doing it. Second thing, as I told you, you can write here also. Let's say I want to write, you can ignore the name, or maybe let me change the name itself, right? I can mention as pod.yaml maybe. Now, as I mentioned, you have already installed the extension. Now you simply type pod. If you type, as you type pod, they will automatically suggest you according to your the kind of the command you put. In my case, I simply typed as pod. So automatically the VS code, that is a Visual Studio Code, because we have installed the extensions, it is suggesting us to select one among them. So there are many. If you have more option, you can see more. But in this case, similar name, I can see two. One is a Kubernetes pod. Second is a horizontal pod autoscaler. What is this one also? This is an advanced. We will not talk for now. Let's focus only this one. If I click here, you can see automatically new pod. It is going to be created. Now question is, it is not just about creation of the pod, but then we need to understand logically how it works in the backend. What kind of components involved in order to write the pod. Okay. Now, as I mentioned, there are two ways. One is this thing. Now, let me copy this also because I want to compare it difference. This is from documents. Okay, I will type this also. Why it is coming? Reason why now the error is coming because the same thing we are using name. Now we need to change some name. Maybe it's okay. Because they are same type, right? That is the thing. Because here also pod is also, if you see here, the map must be unique. Okay. Anyway, I don't care for now because our focus is to topic. Now let me just show you. Let me take an example of the documents first. Here, what we need to understand, as I mentioned, first thing API version, this was API version. Second thing is a kind, here also pod, they mention pod because of course we are using pod. Third thing is the metadata, here metadata. Under metadata, careful check, this is name. This is the Nginx my app. Now question is, what is this actually? What is the metadata means? It is Nginx, what is this mean? This is metadata is nothing but it is basically the informations of your applications. You can give any name as long as you have defined properly. whatever name you have defined when you build a Docker, Docker image, right? Or once you containerize that one, whatever name that you have built it, same name you define. In my case, if it is a Nginx, you can give Nginx. In your case, if it is my app or any name that you given, it should be as it is. Okay, that means that you understand. Now labels. Labels also why it is important, but if you see here, label is not mentioned. Label is something, this is a additional information. Question is, why do I see your label, but why not in the documents? Because as I told you, this label, it is optional. That means you can define or you can ignore it. But then trust me, in the real time, you should be defining, because you will not have simple, YAML file. You'll be having a big step scripts written. Okay, so that is the reason why automatically in the level. Now let us understand what is levels now. If you see Kubernetes also, if you simply ask what is level in Kubernetes also, if you ask what is levels. Kubernetes levels are key value pairs attached to objects such as pods, nodes, and service. They are used to specify identifying attributes that are meaningful and relevant to use, but do not directly imply, okay, to the code. Now that means now why are we using this one? The reason why we are using here, right, is because we are running application. That is my app, right? Now, if I have multiple other applications also, how do you know which one to map? That's why this is just think of a tag now. In Azure also, we have a service called, not service, I would say features like where we can add a tag also, right? In Azure. So similar way here also we have a tag. That means labeling that one. So this is kind labels. Now in this case, this label also we can give a same name if you want as part of your application. So that means they will understand, oh, this particular application is for this particular tag. I mean, this particular tag is for this particular application. It will be able to identify. This is the reason. All right. As I told you, this is optional. You can ignore for now, maybe this label part, but that's okay if you can understand. Second thing is the content specs. Specs is nothing but specification. Question is what this specification is about. Whose specification it is going to be defined, right? This specification is about your container. Now, what is container again, right? Container, as we have already discussed, right? It is a lightweight and isolated environment where it has your sorry, not Terraform. It has your application code, system libraries, and maybe your any kind of components it has, right? Everything. It is built as a set of together, basically containerized that one. So those are that is what that information I need to specify here. Example, sorry, not example, basically, as you can see here, on the containers, now I need to define the name. Name means what will be my container name, basically. We remember, right, that we create a container, so be given some name, right? So same way, I given some name. Question is, I have given name. So let me take you back last class just to give you some idea, right? Okay. Um, sorry, what is it? Comments to, sorry, ignored me. If you type here, Docker images, right? We have this many example Nginx. This is 10, whatever Nginx whatever we are taking. This all, what is this actually? This is not a container. This is an image. Image means you need to this image you want to deploy somewhere, right? Where are you going to deploy? You are going to deploy to the container, right? So container means To run these particular applications, that is Nginx, you need to have all the prerequisites components, right? So where are you going to deploy? As I told you, we are going to deploy something called as a container. Now, if I type here container PS, sorry, not container PS, Docker PS, you can see I don't have any container running. Now, if you want to, because this is all image, this is not a container. This is just an image. Now, in order to run this image, I need to create a container. That means I need to make the environment available, right? So example, I want to make available for Nginx. Let me take example Nginx, right? How can I make use of that one? Now, if you remember last time, we tried to create a container. So what is the command now? Docker run, right? If you remember, Docker run. Then I need to mention the name. Name of my container. If I give my, let's say, example web app, in my case right now, I can give as web app, maybe dot Perl, something like that. I can give 01. This is my container name. Okay. Now, what else I have to do? I have given the container name. Now, I need to do IIT. Sorry, IIT you can give together, or maybe you can give the side. Right? Then I can give a D. That is a D task mode. Then I can give a port number. What a port in my case? I don't mind giving any port. Now, sorry, 80. What is the image that I want to now? I want to run image for the container. I want to create a container based on this image, right? So I need to define the image name now. Let's say Nginx. Nginx, if I give like this, so before that, of course, you need to define the port also. That's P, right? If you define the port, that means I want to create a container for this particular image, that is a Nginx image. A container name would be this one. So I want to this thing, or maybe if you don't want, or maybe I can remove this. Maybe I don't need to. Okay, that's okay. That will be okay. So image arguments is spelling correct. Maybe I don't need to define. Nginx letters, Nginx. Is it time N or M? Okay, so anyway, I think I type N. Maybe together we can give this thing. Okay, I think something it is N or M, right? So if you check here, I think we have this thing, right? Creation, this thing, last sessions. So I think here I given. If you see here, web app, okay, double dash. I thought I given single dash. Maybe I think that should be fine, right? So single dash also should work. Maybe okay. I don't want to give this one or T. Maybe I given this one, right? Let me remove this one. T not required because we are again using D, right? So T I don't need to define. Let me see. What do I need to use the old dash? Name. Single also fine. Oh, I don't know why it's not taking. Maybe they expect full name. Okay, anyway, so they are here to image. Okay, so now you can see now if I type here Docker PS, now you can see whatever. Now this is a container, right? So this container information is basically this is a complete package. That means this can be deployed anywhere now, right? So these informations now, if I try to define using on Docker describe, just for example. Sorry, not describe, inspect. Now, whatever information is there, all you can check all the configuration. So all that means this information is about what containers, like which image is used, everything. What is this thing? You can see all the state, everything, right? All the information you can see. So this all details is what it is different now. So now this is what in my case, if it is a name that I given container name, let's say in my case, what is the name? I can this name. I can copy this name example. You can give any name that you wish to give, anyway, just give an idea. So this will be used for this particular applications. Uh, so you can change now. Automatically it's asking to change it, but I'll change it. So image. Now image is something you want to build this thing right now. How, from where the image is going to become? Right. This image is basically in order. That's why I told you, right? This image, the image what we have here, this is right now. That means if you use a Docker images, whatever you see, this is stored locally. So as I told you, this normally, if you remember last session, we have pushed to the Azure Container Registry as well as Docker Hub. Now, if you want to take the image from the Docker Hub, you can, otherwise you can take from the Azure Container Registry. So it's up to you, depends on the project. Normally in your real time, you will be using the Azure Container Registry in Azure case. Okay. So that that means you have to give the path. Okay, so that is a location that I have to explicitly define here. Whatever part is then. Then container. Now, as I told you, whenever this we run the container, right? If you remember, yeah, this one we define the container port to expose the container, right? What is the port is using? It is using port 80. That means this port 80 we are using it. So this is why we are defining a container port also, because which port this container listens on. Image mean you can give any URL of the particular image, whatever image part, and then whatever container name also that you wish, you can give any name that you. And this is the metadata for this thing port. So that's where we need to do it. So similar way as I told you, let's remove this one. If I refer this one, you can give any name, port name, whatever name I can give. I can change accordingly, like a container name, image basically the URL you can give, and the resource under here. This is a additional information about your resources. And the resources, let's say, in one particular this thing, how many RAM, basic memory, and a CPU you want. That you can also define that one. So this will be within your port level itself. So that's the thing. Okay. So right now this application is running locally, right? So this is why if you deploy, if you define all the data, this can be we can create with the help of this one. Now, in order to create, as I told you, there are different way of creating. This one way of creating this particular deployment, sorry, port is using here kubectl apply f. We have to use does f, then particular this thing. You don't need to give this particular full URL. It will be a part of your location where you have the file. Okay, so you can define like that. So if once you define this thing, your pod will be created. Then once pod is created, you can check. But then, as I told you, right now you cannot create a pod for now, because if I try to create also, it will fail. The reason is I need to install this Kubernetes cluster. I don't have the cluster ready right now, so I cannot create it. But yes, of course, there will be different way of creating. You might be, or maybe just try to explore. There is a tools called Minikube. I don't know how many of you are familiar. Minikube. Okay. Now, why this one can help you save your money as well as time and everything, right? This is also like if you see here, Minikube quickly sets up a local Kubernetes cluster on Mac, Linux, and Windows. We proudly focus on helping application developer and new application, sorry, Kubernetes users. So instead of creating, because if you had to create this complete Kubernetes cluster, you end up paying a lot of money on just because of doing some practice, right? So it is not easy for you to set up at entire environment. So what we can do, instead of defining that, we can use something called as a Minikube, where it has a complete this is like a platform, open source platform, where it enables you to practice and do all stuffs related to your Kubernetes. So you can create pods and everything. But then one thing we need to understand here is everything does not support as Kubernetes cluster, because this is a free version, right? I mean free one, right? So So definitely there will be certain issues which are not supported. Some commands may be not working as expected, but then still, if you are beginners, definitely this will be the right place for you to practice it. Now, as you can see here, Sabu and blah blah. Again, all the platform they have given some. Just go through this also. You can distinct. Now, question is, how can I set up this one? I don't know. So there are many ways of setting up. First thing we need to understand, there is something called Cube Mini. You have to install this one, kubectl. kubectl is command basically to gets configured to access the Kubernetes cluster control plane inside Minikube when the this thing. So been to install. Now, what is the order to use it? So we can use we can configure it many ways basically. One way is you can use using this thing. If you don't know, maybe I can use ChatGPT. I don't mind asking ChatGPT also maybe, right? So ask ChatGPT also. Let's say I will just simply type here because I have already enabled my Copilot here as part of the VS Code. Let me create one more here file call as maybe just sake of time. I can call a minikube, right? On dot. I can give any extension dot txt maybe which format would be better. Okay, txt is okay. Txt. So I will tell now ChatGPT, sorry, Copilot to basically tell me I want minikube in this folder. How can I define? I do not, the ChatGPT, sorry, Copilot would not understand. So let me, there is an option to upload the context. So as I mentioned, what is the file I want? I want to define Ansha here, minikube.txt. Let me check if I can find it. Yeah, this one, right? Minikube, this is a tool I want. Now inside here, now I will ask ChatGPT, sorry, Copilot to basically give me this return. This was the last that we have discussed right last time, how we were working like that. So now you understood. Similar way. Now today, I will give you some idea so that you get some. Now let me ask Copilot that to create basically Copilot to install Minikube, right? So please give me a step by step installation Minikube okay, Minikube cluster. Please give me step by step Minikube cluster installations for Windows. Mostly, I hope you are using Windows. If you are using Linux, that's okay. You can ask Linux as well. Okay. So Linux, Windows is depends on you. You can ask. I'll mention Linux, Windows for Windows and Linux. Let me give both. Linux, Ubuntu. Let's mostly we'll use Ubuntu. Linux, man, Ubuntu. Okay. So please give me step by step Minikube cluster installation for Windows and Linux, Ubuntu. Process. Oh, I forgot one more ask. I forgot one more thing to tell. I should have told him, told them to create in this particular this thing. They are giving here now. So I will tell them to share in this one. Can you please uh, uh provide or provide the answers? Sorry, provide the steps inside. You can mention the file name. It is a minikube dot txt. They will down now give this thing.
Bro, your
You
voice
can
is
copy
not
paste.
audible if you're speaking.
Okay. Can everyone confirm others? Hello. Okay. So as I told you, this you can share like this. All commands are shared. Now, what you can do like this, you can get it. Okay. Now, as you can see here, these are things that you can explore. Now, there is an option, right? So let me come back. Option, if you see here, this is, you can copy, if you want, you can copy here. There is an option, insert. There is an option to copy. So if you do here, it came automatically here. I just click here, right? By clicking here, automatically this come now. I can close this one now. Now I can check this one. One way I can do, otherwise I can do directly within here. I can use a control I. I can ask here also, but as I mentioned, I didn't want dot. So now you can see the steps. Now they have given all the steps that you want. So Windows, you can refer the documents, documentations and everything, then verify everything. So yeah, that's how we can also explore it. Now, okay, let me keep, I can skip. So that is how you can define, create it. So what we can do, I will give you this also step. You can also try to run this one and see if you can install this one. For Windows, you can see installations, download from here. So refer the documents, then installation for Minikube, calculate everything. So we can give all the steps are given here. So follow these steps, then you can install the Minikube also. Okay. Okay, team. So maybe we'll wind up here for today. In the next session, we will try to install the Minikube also, and then we will see how to execute the commands and also see how each command works. Yeah. So yeah, thank you once again, team, for joining us. See you in the evening. Have a nice weekend. Bye.